Picture this, it's a regular Tuesday and you're scrolling through social media, completely oblivious. Suddenly, the internet goes down. Great, you think, more evidence that we're living in a simulation. Little do you know, the real reason for the outage is far more cosmic. Our sun, the anchor of our solar system, has just decided to clock out permanently in a blaze of glory we call a supernova. So what happens next? Before we start drawing up plans to build underground bunkers or launch ourselves into the vast unknown, let's break down this celestial phenomenon. The sun, despite being a giant ball of gas, is a pretty important part of our existence. But like all good things, even stars have an expiration date. And when they go out with a bang. So grab your popcorn, because this cosmic show is about to get wild. Newsflash, the sun is about 93 million miles away. That sounds like a safe distance until you realize that light, the fastest thing in the universe, takes a little over 8 minutes to reach us from the sun. This means we wouldn't even know about the explosion until 8 minutes after it happened. Once that 8-minute grace period is up, things get real interesting, and by interesting, I mean catastrophic. The first thing we'd experience is a blinding flash of light and radiation more intense than anything we've ever encountered. Sunglasses? Useless. Sunscreen? Forget about it. The intense heat from the supernova would vaporize everything on the Earth's surface. Oceans, mountains, you name it. It would be like trying to microwave a marshmallow over a volcano. Everything just melts away. The blast wave from the supernova would travel at the speed of light, reaching us at the same time as that blinding flash. This wave would be powerful enough to rip our atmosphere right off the planet, leaving Earth as exposed as a raw nerve ending in space. Now, you might be wondering what causes these stellar temper tantrums in the first place. It all boils down to a battle of cosmic forces, gravity versus nuclear fusion. Stars are like giant pressure cookers, fusing hydrogen into helium in their cores, releasing a tremendous amount of energy. This outward pressure from fusion keeps the star from collapsing under its own immense gravity. Eventually, though, the star runs out of hydrogen fuel in its core. When this happens, gravity wins the cosmic tug-of-war and the star's core collapses in on itself. For stars much more massive than our sun, this collapse leads to a supernova, blasting the star's outer layers into space with unimaginable force. Think of it like a cosmic fireworks show, except instead of pretty colors, you get a lethal dose of radiation and a front row seat to the destruction of a solar system. Section 4, Echoes of the Past, Historical Supernova Events. Supernovae are pretty rare events in the grand scheme of things. The last time one happened in our galaxy that was visible to the naked eye was back in 1604. Johannes Kepler, the famous astronomer, observed it and even wrote a book about it. We can still observe their remnants, the expanding clouds of gas and dust left behind by these stellar explosions. These remnants act like cosmic fingerprints, providing clues about the star that exploded and the physics behind supernova. Section 5, Survival of the Fittest and Most Distant, Human Life and Technology After the Blast. Let's say, hypothetically, that our sun did decide to go supernova tomorrow, which it won't, I promise. What would that mean for us Earthlings? Besides the obvious everything dies scenario, there are a few other things to consider. All our technology, satellites, power grids, smartphones, would be fried faster than an egg on the sidewalk on a summer day. And even if, by some miracle, some humans managed to survive the initial blast, life as we know it would be over. No more sunlight means no more photosynthesis, which means no more plants, which means no more food chain. But hey, maybe this is a chance for a fresh start. Perhaps some extremophile bacteria or those tardigrades everyone keeps talking about could survive and evolve into something new and amazing. Section 6, Cosmic Aftermath, the long-term effects of a supernova. When a star goes supernova, it doesn't just disappear, it leaves behind a cosmic mess that can have ripple effects throughout the galaxy. Those expanding clouds of gas and dust contain heavy elements, the building blocks of planets, moons, and even life itself. As these remnants expand and interact with surrounding interstellar gas, they can trigger the formation of new stars and planetary systems. So in a way, supernovae are like cosmic gardeners, spreading the seeds of creation throughout the universe. They may be destructive on a local level, but on a grander scale, They're essential for the continued evolution of galaxies and the emergence of complexity. As for us humans, it's probably best if we just appreciate the sun's life-giving energy while we still have it.